Exponential functions are another really important type of function. Let's talk about the three different representations of exponential functions. So we have formulas for exponential functions that look like this. If we input x, the output will look something like a times b to the power x, where a and b are two numbers. And so for a specific example, we could take f of x equals, let's do 3 times, and I'll make that match the color, 3 times 2 to the power x. So in this example, a equals 3 and b equals 2. And so let's isolate the significance of the 3 and the 2 here. If we take f of 0, then we're looking at 3 times 2 to the power 0. The x becomes a 0. And remember, anything to the power 0 is just 1. So this is the same thing as 3 times 1, which is just 3. So the a here is just f of 0. It's the initial value, or it's whatever, it's the y-intercept if we graph this. So a is the f of 0 value. And to see what the 2 is, let's actually continue these computations and fill in our table here. So we just saw that f of 0 gave us 3 back. All right? If we take f of 1, what happens? So then we have 3 times 2 to the power 1. Because remember, our formula is 3 times 2 to the x. So the x becomes a 1, and then we simplify, this becomes 3 times 2, which is the same thing as 6. All right, and then let's do another row. X equals 2. This looks like 3 times 2 squared. That's just 3 times 4, which is 12. And so we can already see a pattern here. As x increases by 1, what's happening to the f of x values? It goes from 3 to 6, and then 6 to 12. So the common theme here is we're multiplying by 2. So as x goes up by 1, f of x is doubled. And that's exactly, that 2 is the same as the 2 here. So this b value, it's the times pattern. So this is a times b pattern. So here we have times 2. So exponential functions, they're related to times patterns, where the base of the exponent is the number we keep multiplying by every time we increase x by 1. So a is where we're starting, and then we just keep multiplying it by b over and over and over again. And so in this example, if you were to graph this, it starts growing faster and faster and faster. So 3 to 6 is a kind of small jump, but then 6 to 12 is a much bigger jump, and it keeps doubling and doubling and doubling. And so it looks like this. It goes steeper and steeper very quickly. Let's just try one more example, and let's switch things up a little bit. So let's look at g of x, and let's go with g of x equals 5 times, and let's make b something between 0 and 1 this time. So let's go with 0.7 to the x. So in this case, it's gonna, the 0.7 is still telling us what the times pattern looks like. It's a times 0.7 pattern. And if we multiply something by 0.7, we're actually shrinking the value. So we're actually decreasing the y value by 30%. Okay, so this would be exponential decay. It's not growing, it's shrinking because we keep multiplying by this fraction here. And so if you were to graph that, it would look something like this, sort of the mirror image across the x-axis, or across the y-axis.